In this video, we're going to look at an improper integral where we've got an infinite discontinuity in the integrand. So we've got being asked to determine whether the integral from 2 to 3 of 1 over root 3 minus x converges or diverges. Notice that if we try to put 3 into the denominator, we're going to get a 0. So we notice that we have a vertical asymptote here at x equal to 3 for our integrand. So that's what's causing this particular integral to be improper. So much like what we did with the infinite limits of integration, we'll replace the bad limit, which in this case is 3, with a variable, and then let that variable approach 3. Now in this case, since the 3 is the upper limit of integration, we will approach 3 from the lower side, because we have to get closer to the upper limit of integration, or take our limit as b goes to 3 from the left. This integral is essentially integrating u to the negative 1/2, so you'll get a 2u to the 1/2 when you're done. However, we also, if you let u equal the 3 minus x, your du will be a negative dx, and so that's where the extra negative sign is coming from out in front. So an antiderivative for that 1 over root 3 minus x is a negative 2 root 3 minus x. We'll evaluate that from 2 to b, plug in b, and plug in 2. When we plug in 2, we get a negative 2, so that's where the plus 2 is coming from, because that's a minus 2. We plug in b, we get negative 2 root 3 minus b. In this case, we can evaluate this limit with direct substitution by just plugging in 3 for b and getting a limit of 2, which tells us the integral actually just converges to 2.